Okay, so looking at this example, example 2, so sketching the graph of y equals x plus 2, 2 take x cubed. Well, start off with, we'll have a look at the x-intercepts. Okay, so letting 0, y equals 0, plus 2, 2 take x cubed. So we can say either x plus 2 equals 0 or 2 take x cubed equals 0. So x equals minus 2 or and x equals positive 2. Okay, so we get 2 points. Now, because this point is, okay, we've got power of 3, this is likely to be a stationary point of inflection. So just looking at the example, it says, due to the multiplicity of each factor, at x equals minus 2, the graph cuts the x-axis. But at x equals 2, its saddle cuts the x-axis. So it's meaning that the point 2, 0 is going to be a stationary point of inflection. So this is going to be our stationary point of inflection. Now, just need to find our y-intercept. So y equals 0 plus 2, 2 take 0 cubed, so 2 times 2 cubed, which is 8, times 2, which gives us 16. Now we can start graphing. Okay, drawing the set of axes. Put our 2 points in, so minus 2 and positive 2 and positive 16. So we're up here. And we know this point here is going to be a stationary point of inflection. We do have a negative x, so we're going to start from the bottom this time. So cortex, if it's positive, we start from the bottom. If it's positive, we start from the top. If it's negative, we start from the bottom. So start from the bottom, and we know this is going to be a stationary point of inflection. It's going to look something like this. Okay, probably haven't really done it very well because should be a turning point there, roughly. So that's example 2. Example 3 looks at, we've got p of x equals 3x to the 4 take 5x, 3 take 5x squared plus 5x plus 2. So they're getting really long, these equations. So we want to factorize p of x first. So it says factorize p of x and hence show that in equation. So when we see the word hence, we've got to use our answer from the first section. So how do we start? Well, using our remainder theorem, okay, p of what gives us 0. Now, there's not really a easy way to jump into it. So we've got 5 and 2. Minus 5 and 5 will cancel out. I reckon 1 because minus 5 times 1 plus 5 times 1 will cancel out. We'll have a minus 5 here, and a 3 and a 2. So let's try, yeah, so p of 1, so 3 times 1, take 5 times 1, take 5 times 1, plus 5 times 1, plus 2. So 3, take 5, take 5, plus 5, plus 2. Minus 5, and so they cancel, we got minus 5, so yes, equals 0. That's what we want. So we can say x take 1 is a factor. Okay, the textbook does something interesting. So what they say is, since we've done positive 1, let's try minus 1 as well. So p of minus 1. So 3 times minus 1 cubed will be, or to the 4, will be just positive 3. Minus 1 cubed will be minus 1, so that'll be plus 5. Squared, that'll be minus 5. We'll take 5 there and plus 2. So again, we get 0. So we can say x plus 1 is also a factor. So now we've got two factors. So we've got x take 1 and x plus 1. So we already know they're two factors. We're going to be left with a quadratic, so ax squared plus bx plus c. Okay, that's because, okay, here's two x terms, that power will go down to a 2. Now we can say x plus 1, x minus 1 is actually x squared minus 1. Okay, because we've got a take b, a plus b is going to be a squared minus b squared. So it's just going to be a squared, take 1, and then we have ax squared plus bx plus c. So just need to solve that second part. So handy little trick. Again, like our cases before, let's just expand. So we'll have ax to the 4 plus bx to the 3 plus x, so it'll be cx squared, take ax squared, take bx, take c. Actually, I didn't. A has to be that 3, so instead of a I can say 3, and instead of c has to be 2, so minus 1 times what gives me positive 2, well that has to be minus 2. Minus 2 times minus 1 gives me positive 2, so that should be a take. Now we'll have 3x to the 4, and we'll have plus x cubed, taking that as a factor, so b, and where's my cube? There is no other cube. Plus x squared, we can have minus 2 here, and take 3 there, and for the x term, plus x, we'll have minus b there, take 2. So a little bit more complicated than what we're used to. 3x4 plus bx cubed, and this will be minus 5x squared, take bx, take 2, and now we can say this term here next to the x cubed is going to be minus 5, and hopefully this